Welcome to topic number 40 in Richard James Mathematics Resources. Transformation. The human sense of sight is so powerful that at a glance, many of us can identify our schoolmates whom we have not seen for over 25 years, no matter how different they look. Well, I'm hoping that most of my CSEC clients of Richard James Mathematics Resources will not have any classmate who they would have seen since the last 25 years. This will cause our CSEC clients to be a set of students that are very old. This tells us that our transformation is in good hands. If we can identify the similarities in the physical features of an individual after he has increased in size and aged somewhat, well, we may just be able to look at objects less complex and be able to tell if they are similar and in what ways they are similar. The phenomenon is important, not that it helps us to be able to transform objects, but equally as important, it helps us to be able to tell if our result of transformation is correct. If we are building a house from a plan that has a passage running from east to west, but it really should be from north to south, without changing the plan, a rotation by 90 degrees should solve the problem. On many occasions, we have drawn a little sketch of what we want to accomplish. The sketch is a reduction of the actual thing. In order to complete the task, we have to do an enlargement of the sketch. In our little way, we have already become masters of size transformation. We may continue to identify ways in which we have applied transformations informally in order to show that what we will be doing soon is in no way strange. Basic transformations. A transformation is a change in size, shape, position, or orientation of an object. In these basic transformations, we will be establishing the principles that are used to transform objects. The transformations will be carried out on plane surfaces without the use of a grid. In the problem-solving section, we will make use of the graph paper. In a translation, that is our first transformation, that's a translation. All points of the object move by the same distance in the same direction. Lines that are parallel will be drawn from the vertices of a polygon, and the images of the vertices are placed at equal distances from the original. Let's see what that means. Draw lines that are parallel from the vertices. This may be done at sight. It is not impossible to draw lines that appear as if they will never meet. So we are going to draw parallel lines going from the vertices like that. Use your ruler to measure a distance, say 7.5 centimeters from A along the line, and mark that position. So we are doing translation, but we are not making use of graph grid, and we are not making use of the general devices like vectors that are used to translate objects. We are doing our translation on plain paper so that we can have a very detailed understanding of what a translation is. And we are doing that from the very root upwards, beginning with the object and moving to the lines that are parallel, that are going from the vertices. And now we have to understand that the image of the points are equal distance from the original point. So if we are measuring, say, 7.5 centimeters for the image of A, and of course we are just choosing our distance. While doing your translation, you may want to choose a different figure. But of course, you need to get your lines parallel or as close to parallel as possible. So we're going to be using 7.5 centimeters, and we use our ruler. We mark off 7.5 centimeters. The new point is the image of A, called A prime. So we are going to do the same thing for B. So we're going to use the ruler and measure from B 7.5 centimeters. The new point is the image of B, called B prime. And we are going to be doing the same thing for C, measuring 7.5 centimeters along that line that goes from C. And that 7.5 centimeters is measured from the vertex C. And that is our image of C, called C prime. Complete the polygon in order to form the image of the original triangle ABC. And of course, we are going to translate a quadrilateral this time. And of course, we are going to take the same approach. Draw lines that are parallel from the vertices. We are just establishing the basic principles of translation. Later on, we will use the grid. So, parallel lines are leaving. So use your ruler to measure a distance, say 9 centimeters. And of course, we are choosing our 9 centimeters. You may choose another value. So 9 centimeters from A along the line, and mark that position. So we are going to take from the vertex A 9 centimeters, and that is where we are going to put our point A prime, which is the image of A, and the new point is the image of A, called A prime. And of course we are going to measure that same distance from the vertex B, and the new point is the image of B, called B prime. So the next thing, measure the same thing, 9 centimeters from C along that line, and that image is C prime. And finally, we are going to do the same thing with D, 9 centimeters, and that image is called D prime. And of course, we are going to complete the polygon, and completing the polygon, what do we have? We have an object that looks exactly like the one that we have before, and it just appears to be shifted down somewhat. So in every respect it resembles the original. After translation, the relationship between the object and its image is as follows. So 1, they are the same size, they are the same shape, they have the same orientation, and corresponding sides are parallel. Notice this AB line that goes there seems to be going in the same direction as A prime, B prime. And look at BC, and notice that the corresponding sides are parallel. Notice this and this, right? So corresponding sides are parallel. Now, since we have the image resembling the object in every respect, we are saying that Instead of outlining all of the similarities between the object and its image, we may say that they are congruent. That means equal in all respects. We are just going to be looking at reflection. When reflecting a point, the line joining that point to its image is perpendicular to the mirror line. The distances between the points and the mirror line should also be equal. So there we have our object, a triangle ABC, and here we have also the mirror line. To reflect the point A in the mirror line, first let the straight edge of the protractor pass through the point A, while at the same time the 90 degrees line of the protractor is covering the mirror line. So let's see how that is done. Notice that the straight edge of the protractor is passing through the point A, and the 90 degrees line of the mirror line, see, 90 degrees, although the protractor is upside down, is in line with the mirror line. That is so that the line that we are going to be drawing from A straight across here will be 90 degrees or perpendicular to the mirror line. So we are going to draw a line that goes from A across the mirror line and should be greater than or equal to the distance from the mirror line to A. Now we are going to draw a line from A across the mirror line to the other side where we will locate the image of A. However, the distance between A and the mirror line should be equal to the distance between the mirror line and the image of A. Therefore, the line that we are drawing, it should go somewhat beyond, or at least equal to the same distance that we are going to determine from A to the mirror line. So let's see how that is done. We are going to draw the line first. There we have the line. Then we are going to measure. So measure the distance from A to the mirror line. Yes, so we measure the distance from A to the mirror line, and we take note of that. Distance is 3.8 centimeters. Therefore, what do? We measure the same distance, which is 3.8 centimeters, from the mirror line on the other side, and in such a way that we may be able to locate the position of A prime. There we move the ruler and measure that same distance, 3.8, on the other side, and we mark that right there. So that is our image of A, and it is called A prime. Now, when reflecting a point, the line joining that point to its image is perpendicular to the mirror line. Therefore, we are going to construct a line that passes through B that is perpendicular to the mirror line. And of course, that is done by let the straight edge of the protractor pass through the point B, while at the same time the 90 degrees line of the protractor is covering the mirror line. See, the straight edge of the protractor is passing through B, and the 90 degrees line of the protractor is on the mirror line. And of course, we are going to draw the line that goes from B across the mirror line. And of course, that line should be basically drawn in such a way that it will exceed the distance from here to here, or round about the same distance should do. So the line is drawn, and what do we do now? Measure the distance from B to the mirror line, and that distance is 2.7 centimeters. So we measure 2.7 centimeters on the other side, and there will be the position of B prime right there. We are going to reflect the point C. So notice that the protractor is turned right side up this time, but that should not affect the construct in any single way. As long as the straight edge of the protractor is passing through C and the 90 degrees line is in contact with the mirror line, then we are sure that our approach is going to be correct. So we need to draw that line that goes from C across the mirror line to the other side. And of course, what do we need to do next? Measure the distance from C to the mirror line. And that distance is 1 centimeter. Measure the same distance of 1 centimeter from the mirror line in order to locate the position of C. So we are going to shift our ruler so that we'll begin measuring right here. Right. And we are going to be locating the image of C right there. I'm sure that on the slide the students are able to see, for the most part, the numbers that are here. This is saying 20, 30, 40, 50. But do not forget that this edge of the ruler is being used to measure millimeters, and this one is given in centimeters. And of course, no problem, 10 millimeters is equal to a centimeter, so the conversion should not be any problem. Another thing to take note is that where we start measuring from on the ruler is not actually at the edge of the ruler. So you will notice that most times the edge of the ruler is not at the beginning point or the point from which we are measuring, but the ruler is placed in such a way that, which is this line that we have here, is indicating that this is where the measurement should start. So we will not really be starting all the time at the edge of the ruler. So we are going to complete our diagram, and that is our image of our triangle ABC. And of course, it is called A prime, B prime, C prime. The relationship between an object and its reflection is as follows. They are congruent. They do not have the same orientation. To check for the orientation of the objects, read the vertices A, B, C, and notice that for the original, this is a clockwise movement. If the same is done with the image, it will result in an anti-clockwise movement. Notice that this, let us do it. A, B, C. Notice A, B, C, going in a clockwise direction. Notice now that when we check the orientation for the image, what do we have? A prime, B prime, C prime. So we go A prime, B prime, C prime, A prime, B prime, C prime. So we are going in an anti-clockwise direction or counterclockwise direction, and because of that, we say that the object and its image are different in orientation. This time we will reflect a quadrilateral using the same principles. Reflect the point A by constructing a line through it that is perpendicular to the mirror line in the usual way. So we're going to be using our protractor. The straight edge of the protractor passes through the point A, and the 90 degrees line of the protractor is right on the mirror line right there. And of course, we are going to draw our line across there, going from A across there. And as usual, measure the distance from A to the mirror line. And that distance is 1.1 centimeter. Then we will also measure that same distance of 1.1 centimeter from the mirror line, and that position will be the image of A called A prime. So now we are going to reflect the point B, and we are going to use the same construct. So straight edge of the protractor passes through B, and the 90 degrees line of the protractor is right on the mirror line like that. And then we draw that line across. After that, measure the distance from B to the mirror line. The distance is 2 centimeters. And then we measure the same distance from the mirror line, and that position will be the image of B, called B prime. Let us do the same thing with C. Reflect the point C by constructing a line through it that is perpendicular to the mirror line. Draw a line that goes from C across the mirror line. How did we arrive at it? Straight edge of the protractor. Straight edge of the protractor passes through C, and the 90 degrees line of the protractor is on the mirror line. So let us measure the distance from C to the mirror line. That's about 5 centimeters. And of course, we need to measure 5 centimeters on the other side from the mirror line, and we will locate the image of C, which is C prime. Let us now reflect the point D by constructing a line through it that is perpendicular to the mirror line. Of course, in much the same way that we have done before. However, notice what is happening right here. The 90 degrees line of the protractor is exactly on our mirror line. However, the protractor does not get to the line D. We will therefore use a ruler to help us complete the journey. So in the case that the straight edge of the protractor is not long enough to get to the point, accompany it with a ruler. And that we have done, then we carefully remove the protractor and use the ruler to draw the line that goes straight across as usual. Then we are going to measure the distance from D to the mirror line. That distance is 5 centimeters, and we need to measure from the mirror line to the other side 5 centimeters and locate the image of D right there, D prime. So here we have all of our points, and we will complete the quadrilateral by drawing the lines. Remember that in a reflection, the object and its image are different in orientation. As a matter of fact, this is the only transformation in which the object and its image are different in orientation. A question may require that a transformation be identified, and this property of reflection distinguishes it from rotation. I'm comparing it with rotation because the two are sometimes confused. No one will confuse size transformation with any other. Well, I hope that the reason is obvious, and I will not insult anyone's intelligence by mentioning it here. An object and its translation are exactly the same. It appears as if the object is just lifted up and placed at another location in exactly the same way. If a transformation is not a rotation, at least we can positively determine that it is not. Now we are going to show that if we do not have a protractor, or if it is better to our taste, we may use a set square rather than a protractor. So place one of the perpendicular sides of the set square in contact with the mirror line, and the other one should pass through the point C. So notice that this is our 90 degrees of the set square. One of the sides that make up the 90 degrees angle is placed right in contact with the mirror line, and the other 90-degree side passes through the point C. What do we do then? Place the ruler in contact with the set square in such a way that it goes from the point to be reflected, which is D, to the other side of the mirror line. So it goes right there, and we complete our diagram by drawing the line across there. And as usual, we take the same step to measure the distance, and the distance there is 5 centimeters, and that distance is also repeated on the other side in locating the image of the point D, and that's D prime. Draw the image of ABCD by completing the polygon. Now we're going to be looking at size transformation. In a size transformation, the distance of the image of each point from the center is equal to the distance of the original point from the center multiplied by the scale factor. Draw lines from the center through the vertices to some distance beyond the vertices. The scale factor is 3. Therefore, each image will be 3 times the distance of the original from the center. So we are going to be size transforming the triangle ABC, and of course we are going to be using a scale factor of 3. Therefore, the distance between the center of size transformation and a point is going to be far less than the distance between the center of size transformation and the image. So the distance between the center and the image point is expected to be very much larger than the distance from O to B. And that is why we have these lines going all the way up here, and this one going all the way across here, and of course this one goes some great distance down there. So measure the distance of A from the center. This original statement that we have here might be just more than a mouthful, but the exercise that we are going to be carrying out right here will clarify what this statement is all about. Measure the distance of A from the center. Right. The scale factor is 3. As a matter of fact, let's see what the distance is. The distance is 2.4 centimeters. So we're going to multiply 2.4 by the factor 3. And the result is 7.2 centimeters. So because the scale factor is 3, we find the distance from O to A, then multiply that distance by 3. Then of course, locating the image of A, we are going to measure that 7.2 centimeters again from the center along that line. And that 7.2 is our location of the image of A, called A prime. We are going to do the same thing with B. So measure the distance of B from the center. The distance is 3.3 centimeters. So multiply the 3.3 by the scale factor of 3, and the result is 9.9. The image of B will be 9.9 centimeters from the center. Measure the distance of C from the center. The distance is 4.5 centimeters. So we need to multiply 4.5 by 3, and the result is 13.5. Therefore, the distance of the image of C from the center of enlargement will be 13.5 centimeters. Take note that when we measure from O to A, multiply that result by 3, the distance is measured from O to A prime. And when we measure from O to B, the distance is multiplied by 3, and the distance again is measured from O to B prime. So all measurements are done beginning at the center of enlargement. So let us complete the triangle. Lovely. The relationship between an object and its image in a size transformation is as follows. 1. They have the same shape. Corresponding sides are parallel. The length of a side of the image is equal to the length of the side or the corresponding side of the object multiplied by the scale factor. Therefore, if from A to B is, say, 2 centimeters, from A prime to B prime should be 2 times 3 equals 6 centimeters. And we have more. The area of the image is equal to the area of the object multiplied by the square of the scale factor. When we are finding the area of the image, we multiply the area of the object by the square of the scale factor. And E, they have the same orientation. And F, if the scale factor is greater than 1, the result is an enlargement. If the scale factor is less than 1, the result is a reduction. And we are going to be looking at a reduction on the next slide. In this case, the quadrilateral will be size transformed by a scale factor of a half. Use pale construction lines to join the vertices to the center. Of course, in this particular case, the line that join the vertices do not need to go beyond the vertices that we have here. That is because the scale factor is a half, so the distance of the image will be a half of the distance of the object from the center. Measure the distance OA. The distance is 11 centimeters. So multiply 11 by a half and the result is 5.5. The image of A will be 5.5 centimeters from the center. The scale factor is a half, therefore it was not necessary to extend the construction lines beyond the original points. The image is expected to be closer to the center of the size transformation than the original. So measure the distance OB. So we are going to say 13.4 multiplied by a half is equal to 6.7 centimeters. The image of B will be 6.7 centimeters from the center. Measure the distance OC. And that's what? 9.4 centimeters. So the 9.4 is multiplied by a half, and the image of C is 4.7 centimeters from the center. And we are going to be finishing up with D. That distance is 8.7 centimeters. 8.7 multiplied by a half is equal to 4.35 centimeters. We may round this off to 4.4 centimeters. The image of D will be 4.4 centimeters from the center. Complete the polygon. Right. And that is our image. Notice, of course, it's reduced in size, and of course, if we should take a good look at the corresponding sides, we will see that they are parallel. And of course, they have the same shape and the same orientation. Our final subtopic is rotation. So in this subtopic, an object will be rotated through the specified angle about the given center of rotation. This is achieved by rotating the vertices of the figure. There we have our first assignment to rotate the triangle about this center of rotation. And in order to do that, we need to connect the vertex to the center by using a straight line like that. We may do all of them to begin with, or we may just do the one for A, and then when we are transforming B, we draw another one for B. So place the center of the protractor at O with the zero line in contact with the line that goes from O to A. And of course, in this particular assignment, we are rotating that triangle by 90 degrees clockwise about that center, which is O. So we are going to get our 90 degrees by placing the protractor, center of the protractor, at the point to be at the center. Place the center of the protractor at O, which is the center of rotation, and the zero line is in contact with the line that goes from O to A. Notice here is our zero line. Of course, you may look and see this is 180 degrees, but do not forget that your protractor starts 0 on this side and goes up to 180 on this side, also starts at 0 on this side and goes to 180 on the other side. So this is no doubt our zero line, and we are going to mark the 90 degrees right there, and we are going to draw the line that goes from the center right there through that 90 degrees, in order that this line will be 90 degrees to the one that we are constructing there. Right. Then we need to measure the distance from O to A. There's our ruler again. OA is 6.1 centimeters. Of course, that 6.1 centimeters is going to be measured along this line in order to locate the image of A, which is of course A prime. So that is what we are going to do now. So we are going to measure that 6.1 centimeters right there, and that is our A prime. So we are going to do the same thing with the point B, draw a line that goes from O to B. And of course, we are going to place our protractor on the line in such a way that the center of the protractor is at the center of rotation. That is, the center of the protractor is at the center of rotation, and the zero line of the protractor is on that same line that goes from the center of rotation to B. Then we are going to mark our 90 degrees position, which is right there, and we are going to draw a line that goes from the center to that point right there. Then we are going to use our ruler. So we need to measure the distance OB. Whatever we get, say 8.2 centimeters, we are going to measure 8.2 centimeters from the center of rotation to locate the image of the point B, which we will call B prime. So 8.2 centimeters along that line, and that's our B prime. What are we going to do with the point C? We may not use a protractor to rotate this one. We may use a set square, but let's see. That's our set square. So we are going to place the 90 degrees vertex at the center of rotation. And of course, because we want a 90 degrees that goes from C to the image of C, we are going to use one of the edge of the 90 degrees vertex, which is this one in this particular case, and then the other 90 degrees edge will go in this direction. Of course, this is so that we can draw our line 90 degrees. Of course, this edge that we have here, these edges are perpendicular to each other, so no problem getting our 90 degrees there. So let us draw the line that goes down like that, along that edge. Right there. And then we measure the distance OC. And what's that? 4.2 centimeters. And then we are going to measure that same distance from O to C prime. And mark that. So in our rotation, 90 degrees may be obtained by using our protractor, and of course may be obtained by using the perpendicular edges of a set square. So we are going to draw the line in order to connect the vertices, so we may have the image of our triangle, and that image is called A prime, B prime, C prime. When an object is rotated, the relationship to its image is as follows. They have the same size, they have the same orientation, they have the same shape. We may say that they are congruent. Now we are going to be rotating a quadrilateral by 180 degrees. This is angle on a straight line, so we need no protractor in doing that. Remember, 180 degrees angles on a straight line. So from each vertex of the quadrilateral, draw a line that passes through the center of rotation to some distance on the other side. So there's our line. Well, we have 4 lines. Measure the distance from A to the center. That's 8.5 centimeters. Measure the same distance, 8.5 centimeters, from the center on the other side. And of course, there we will have the position of A prime, which is the image of A. Notice that this rotation by 180 degrees turns out to be very simple, because 180 degrees is an angle on a straight line. So use our straight line, measure from A to O, then from O to A, and that should be the image of A under a rotation of 180 degrees. See, that line that we have going from B is a straight line that goes straight across. So because it goes straight across, we are sure that the angles associated with it is 180 degrees. So measure that distance, 7 centimeters. So measure 7 centimeters also on the other side. And that is going to be the location of our image of B, called B prime. Do the same with C. So measure the distance from C to the center, and that distance is 7 centimeters. So measure the same distance on the other side and locate the image of C. And also, finally, measure the distance from D, and that distance is 12 centimeters. So measure the same distance on the other side in order to locate the image of D. And see, our rotation 180 degrees need not be described as clockwise or anti-clockwise, because whether clockwise or anti-clockwise, the image will be located at the same position. The image of ABCD may be completed by joining the vertices. And there we have our 180 degrees rotation of our original figure. Composition of transformations. When transformations are combined, some results can be interesting and some may be given special names. The first one that we're looking at is the composition of reflection and translation. Of course, that is in any order. So if we do a reflection, then a translation, or a translation, then a reflection, that composition is called a glide reflection. Then we have this double reflection. If we reflect an object twice, two different mirror lines that are parallel, the result is going to be a translation. But if the mirror lines are not parallel, the result is going to be a rotation. So double reflection in parallel lines results in a translation. Double reflection in lines that are not parallel results in a rotation. We have come to the end of our lesson.